Alright, Math 8 kids, this is Mr. Kim. Sorry I can't be here right now. I'm a little sick, so yeah, not feeling up for it. In any case, if I sound a little tired or I start mixing up my words, again, I apologize. We're going to take a 2-day lesson and put it into 1 day. Teacher, if you haven't given out the handout yet, please give the students the handout and pause this video. Alright. So you guys all have the handout. Your iPad should be up and running. No time for slow, even if I'm sick. All right, we're doing problems 53 to 55. We're still going to do 51 and 52, but we're going to do it together. It's going to be like our notes, so that you guys can then start doing 53, 54, and 55. Okay, so let's get into it. You guys are pretty much going to figure out, first of all, do you have a triangle? That's the first important question. Second, if you do have a triangle, what kind of triangle is it? Is it an obtuse, acute, or right triangle? So we're not just going to use observation, but we're going to use calculation to determine this, okay? So again, first of all, do you have a triangle, right? Do we have a triangle? Because a lot of kids, they skip this step. And then, if we do have a triangle, is it an obtuse, an acute, or a right triangle? Let's define, let's write that down. Step 1. Triangle, question mark. Write that down. Do we have a triangle? Okay. Step 2, type. Let's write down the types. We've got obtuse, which means you have an angle greater than 90 degrees, right? Then we have acute, should be coming back to you, less than 90 degrees. And then finally we have a right triangle, which means you have exactly 90 degrees. We're talking just one angle. So one angle will be obtuse for an obtuse triangle, which is greater than 90. All angles will be less than 90, which means that it's an acute triangle. And if one angle is equal to 90, that's a right triangle. Okay, so get this written down. And 3, 2, 1. All right, we're going to go over to your handout real quick. Actually, sorry, before that, we're going to go over some pictures here. Yes, I want to discard that. All right, so I took some pictures earlier. Where's the one I wanted to show you? That is this one. Take a look, okay? Might be hard to see, but this is a length of 3. This is a length of 4. And this is a length of 13. What am I saying? Okay. Why are there squares here? Because we're going to look at the square of these side lengths to help us determine what kind of triangle we have. But first, we need to look at the side lengths themselves to figure out if we have a triangle. So check this out. This triangle here has a length of 3. This triangle has a length of 4. These are connected. This triangle has a length of 13. Okay. Notice that this here and this here, they don't connect at all. Some of you might be thinking, yeah, they do. They connect on the green one. No, the green is there just to help you see that something else. In any case, here's a right angle. So some of you might be thinking, Mr. Kim, this is obtuse. No, it's not. For a triangle to be obtuse, all 3 sides have to meet. Because 13 is so long, the 4 cannot connect with the 13 right here. So there's some empty gaps. Even if we were to make this flat right here, go along, it would only go along 7 units. Because this is 13 units long, you're never going to meet. So pretty much, if the 2 smaller sides, 3 and 4, aren't larger than the longest side, 13, you don't have a triangle. I'm going to say that again. If the 2 smaller sides, 3 and 4, so we're going to call this small, we're going to call this medium. If the small and medium aren't larger together, 3 plus 4, 7, if that's not larger than the longest side, you don't have a triangle. It's very simple. One more time. If the small side and the medium side, the sum, if it's not bigger than the longest side, which is 13, then you do not have a triangle. Okay, so right now we just need to observe and we'll make sense of this later. Let's go to a right triangle. Oops, too much. Here is a right triangle. If you can see it, that's what the green is for. So the green is to show you a perfect right angle. Okay. Now this length is 3. I know you see 9, but that's how many squares there are in here. And I told you just a while ago, we're going to use the squares to determine what kind of triangle we have. This is a unit of 4, right? You can count it, 1, 2, 3, 4. And this is a unit of 5, 1, 2, 3, 4, 5. In this case, we have a perfect right triangle because this is a right angle. Now, let's see if what we just figured out previously works. 3 plus 4 is 7. 7 is greater than 5. Therefore, we have a triangle. So then how do we determine if we have a right triangle? I want you to take these two numbers real quick and add them. Not the 3 and the 4, but the squared versions of 3 and the squared versions of 4. 9 plus 16. 9 plus 16 is 25. So is 5 squared. Notice how we squared everything. 3 squared, 4 squared, 5 squared. If we square the sides, we can figure out if we have a right triangle or not by taking the squares, the 9 and the 16, and seeing if they make the other third square, which is 5 squared. So 9 plus 16 is 25. They are the same. This plus this, or this square plus this square, equals this square. 9 plus 16 is 25. They are equal to 25. If that is the case, you have a right triangle. Okay? A couple more examples. Let's go to an obtuse. That's the one we already showed you. Let's go to an acute triangle. In an acute triangle, notice how this angle is right. There's the 90-degree angle right up here. It's actually shrunken in, so now it's not 90 anymore, so it's less than 90. So this is acute. Let's check our sides. 4 plus 5 is 9. 9 is greater than 6. This is 6 units long, right? So therefore we have a triangle. Let's compare the square sizes. 16 plus 25, if you can't do that in your head, don't worry, but 16 plus 25, which are the smaller squares, that's 41. 41 is bigger than 36. So if the a squared and the b squared, or this square plus that square, if that's bigger than the largest square, right, the small square is bigger than the large, and small and the medium square are bigger than the largest square combined, right, that's a 41, then you have an acute triangle. Say that again. If the small square plus the medium square, sum, 41, is greater than the large square, which is 36, 41 is greater than 36, you have an acute triangle. And lastly, let's go to an obtuse triangle. Here's an example of an obtuse. Notice how all three sides match up. Again, let's check our side lengths. 3, 4, 6. 3, 4, 6. 3 plus 4 is 7. 7 is bigger than 6. We have a triangle. So what about the squares, right? 3 squared is 9. 4 squared is 16. Well, if I add 9 and 16, that's 25. But that is not bigger than the large square. So the small square plus the medium square is smaller or less than the large square. That means you have an obtuse triangle. Let me say that again. The small square, 9, plus 16 is 25, which is less than 36. Where are we getting these squared numbers from? That's because we are squaring the side lengths. 3 squared, 4 squared, 6 squared. I'm trying to drive the point home because you cannot move on from today without knowing this. So if you don't get it by now, I'm going to give you time to talk to the people at your table. So teacher, please pause this video, ask the kids to talk to each other. If you hear nothing, move on. But if you hear some discussion, please let the kids discuss, and then feel free to play the video when you're ready. 3, 2, 1, go. All right, hopefully you got that worked out. What we're going to do is summarize this information now. So all these photos are going to go away. Let's get into your handout here. So we're going to use the actual sides that we worked with. So for a not triangle, right, we're going to start here. I'm going to write a little note. Not triangles. Number 1, start here. First, you have to determine if you have a triangle or not. Okay? If you don't have a triangle, then there's no point in figuring out if you have an obtuse, acute, or a right. Am I making sense? The first mistake kids make on their test or quiz is that they assume that they've got a triangle, an acute, obtuse, or right, and they're on a mission to try and find it. But here's the thing, if your sides don't even make a triangle, then there's no point. This is meaningless, right? This all, like if you don't have a triangle, you can't even figure out what kind of triangle it is. Am I making sense here? Okay? So, the triangle we analyzed that was not, and we're going to place it right here where it says side lengths, was a 3, a 4, and a 13. Notice how we're going small, medium, large, right? That's what the SML stands for, small, medium, large, okay? Now, forget the area. Forget the area. We don't even care about the area. In other words, we don't care about the squared, right? The squared version of these. Real quick, 3 plus 4, right? Let's put a plus sign here, okay? So small plus medium is less than the large. for not triangles. So small plus medium is less than the large. So that's a 7 less than 13. And on the side, I'm just going to write 7 less than 13. You do not have a triangle if that is the case. Okay, I'm going to give you another one. Let's do 5, 6, and 13. So put 5 here, then put 6, then put 13. Again, let's add the 2. 5 plus 6, right? That's 11. Is 11 bigger or smaller than 13? I believe it is smaller. It fits the pattern of less than, which means you do not have a triangle. 11 less than 13. This is not a triangle at all, right? So, 3 side lengths, I know it's kind of covered up by this sign here where it says this area desktop, but at the bottom it says 3 side lengths will not make a triangle if, and let's write this down, if small plus medium is less than large. Okay? If the small side plus the medium side is less than the large side. Okay? Let's put the word sides down here because some of you might forget that we're talking about side lengths right now. Now if you look at the way bottom, it says 3 side lengths will form a triangle if all we're going to switch it is to a greater than sign. Because if these small ones, 5 plus 6, let's say it was 5 plus 9, right? 5 plus 9 is bigger than 13, right? 5 plus 9 is 14. Then you do have a triangle. So 3 side lengths will form a triangle if the small plus the medium, if S plus M is greater than, circle that, is greater than the large side. All right? So you start here. Without this, you cannot figure out anything. Okay? So if you figure out that you don't have a triangle, great. Problem's done. But if you do have a triangle, well then now you have to figure out, is it an acute, obtuse, or a right triangle. So let's go to a right triangle real quick because we already did that one, and that was 3, 4, 5. So let's fill out the side lengths here, 3, 4, 5. 3, 4, 5. Now real quick, let's just add the 2, right? 3 plus 4 is 7. 7 is greater than 5, which means it fits this pattern. It will form a triangle. Now, area of square. What they want us to do is square the 3, square the 4, square the 5. So 3 squared is 9. 4 squared is 16. 5 squared is 25. Notice that if I sum the 2 together, I'm going to put a big plus sign here, it's going to be equal to the large square. Okay, so again, put this down. S plus M equals L. 9 plus 16 equals 25. Let me give you another example of 3 sides that do form a right triangle. Okay, let's go 5, 12, and 13. Now some of you are like, well, that's too big. The numbers are too big. It doesn't matter. Let's just see if we make a triangle first. 5 plus 12, 17, greater than 13. Right? 5 plus 12, 17, greater than 13. So we're good. So we're going to square these now. 5 squared is 25. 12 squared is 144. And 13 squared is 169. Now, I'm not going to ask you to do the addition, but if you add 25 plus 144, you do get a 169. So that means that this pattern holds true. Okay? Now, those are the only 2 examples I'm going to give you because you have more that you're going to work out. But let's fill out the bottom here. If 3 squares have sides that make a right triangle, then the sum of the areas, we're talking about this. Let's just draw an arrow down to here to help us know what we're talking about. The sum of the areas, notice how we're area here. The sum of the areas of the 2 small squares, meaning small plus medium, is going to be equal to the large. So the sum of the areas of the 2 small squares equals the large square area. Why are we writing so many words here like large square area? Because I need you to understand we're squaring the side length. In other words, we don't care about the side lengths anymore once we square them. Okay? So we need this. Alright, so let's write it down real quick. Small square plus medium square equals large square. Okay? I don't like to write L lowercase because it looks like a 1, so that's why I use cursive. So small square plus medium squared equals large squared. That's what this is saying. Okay? We're almost done with this part, and then you guys are going to be free to work because this is problem 53 right now. Acute triangles. Let's go here for a second. Remember, in an acute triangle, okay, well, let me give you an example of acute triangle. Let me give you an example. of acute triangles. Okay, in an acute triangle, well, let me verify because I want to make sure that I'm not wrong. All right, so I just wanted to verify my numbers. In an acute triangle, we found out that the small squared and the medium square were bigger than the large square. So let's use the actual sides that we dealt with in the problem. Here we go. It was a 4, a 5, and a 6. Okay, let's do a quick check. 4 plus 5 is 9. 9 is greater than 6. It's a triangle. So let's square these numbers. 4 squared is 16, 5 squared is 25, and 6 squared is 36. Okay, if I add these two together, just like I did before down here with the right triangles, if I add these two, that's a 41. That's bigger than 36. So the pattern here is if I add, I'm going to be greater than the large square. So 16 plus 25 is greater than 36, right? Because 16 plus 25 is 41. All right. So let me give you another example where this is true, right? So we're not just gonna move on and make sure that we don't understand. Let's do 7, 9, and 12. Okay, so I'm just making numbers up now. They're a little bit bigger because we got to get used to them. 7 plus 9, 16 is greater than 12. It is a triangle. 7 squared is 49. 9 squared is 81, and 12 squared is 144. Now, if I add 49 plus 81, I'm just going to do the addition real quick. That's 130. 130, actually, I'm totally off. Sorry, I forgot to, I need to change my number. Let's erase. It's not a 9. Sorry, I read it wrong, guys. It's a 10. So let me change it. 10, which is 100. Okay, so 10 here, sorry, 100 here. That's a 149. And 149 is bigger than 144, so that fits this pattern. Okay, so this is how you can calculate. All right, so let's come up with this little thing down here. If 3 squares have sides that make an acute triangle, then the sum of the areas of the 2 small squares, these numbers, is larger or it is greater than the large square area. Okay, and I'm going to write a little mini formula here. So s squared plus m squared is greater than L squared. Again, these are the side lengths. So we square them, it's bigger than L squared. Which leaves us then with our obtuse triangles. Okay, so let's do this real quick. We already did an obtuse triangle. I'm going to do this much quicker only because you guys kind of get the pattern now. So, or I'm assuming at least. The obtuse was 3, 4, and 6. That was the one we originally looked at. If I add that, that's bigger than 3, 4 is bigger than 6. So 9, 16, 36. Okay. If I add 9 and 16, that's 25. Again, if I add 9 and 16, that's 25. That's smaller than 36. So that's the pattern here. You need to understand that. Okay. So let me give you another one that works out this way. Let's do 5. 6 and 10, right? 5 plus 6 is 11. 11 is greater than 10, so it's true. Now we have 25 and 36 and 100. So 25 plus 36, I'm going quicker now because hopefully you see these. 25 plus 36 is 61. 61 is smaller than 100, which fits this pattern. So these are just examples that they would have made you gone through, and I'm just doing it with you. So let's sum this up. I'm going to erase the start here sign. If 3 squares have sides that make an obtuse triangle, then the sum of the areas of the 2 small squares, these guys, is less than the large square area. Let's make a little formula. S squared plus m squared is less than L squared. Okay? So you now have patterns. Okay? Let me sum this up. Figure out if you have a triangle first. Are the two sides that are smallest, are they bigger or smaller than the longest? If it's smaller, right, you don't have a triangle. If it's greater, right, you do have a triangle. We circled it. Then you use the squares. You square the small, medium, and large side to get these bigger squares. Remember the squares we showed you earlier. And you use the squares to figure out, do I have an acute, do I have an right, do I have an obtuse? You're going to want to utilize this for the next couple of days because some of you, it's hard to memorize. Memorizing is the worst thing. Understand. Okay? When I add the two small squares and they're equal, that's a right triangle. When I add the two small squares and they're bigger than the large square, okay, that's an acute. If I add the two small squares and they're smaller than the large square, that's obtuse. And you kind of have to replay that pattern in your head over and over again. So this is going to go away in 3, 2, 1. Pause the video, teacher, if you need to. Here we go. 3, 2, 1. And let me switch back to our classwork. Okay. So we kind of did 51 and 52 and 53, right? Like all this stuff, if you look, if 3 squares have blah, 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 right? So we already did that. So now you guys are going to do 54. Your job is to figure this out. We kind of did some for you, kind of, sort of. But your job is to figure this out, okay? Figure this out. Use the patterns you found to predict whether each of the set of lengths will form a triangle. There's that first question, do I have a triangle? So answer yes or no, show your work, okay? And then if a set does form a triangle, show your work and state whether it's acute, obtuse, or right. So don't just copy down someone's answers. Make sure you understand this. There is no reason why you leave today without being able to at least do this on your own or at least get some help so that you can do it on your own. You have that little handout page for you. You can work on the back side or work at the bottom if you have space. Work these out, and then you have an additional challenge here, which is something you want to work with your group about. Okay? So that's it for me. Good luck. I will see you tomorrow, and I hope I feel better. 3, 2, 1, goodbye.